Great, thank you very much. Unfortunately, I am going to have to dash off before 1, so I'm pretty gutted to not be eligible for the free lunch. But yeah, thank you everyone for coming today. So I'm going to speak through some work that we actually published this morning, so hot off the press, on what's needed to align with 1.5 degrees by 2030. Why did we do this analysis? Well, we've taken a look at the latest scenarios that have been assessed by the IPCC in its very influential 6th assessment report. And these are fantastic scenarios. They give very important information on how to address climate change, but not all of them are compatible with the Paris Agreement, and not all of them are compatible with getting to net zero in a sustainable way. So what we did is, and I would say that if those scenarios are then used to set global targets, they could be quite damaging. They could suggest things that we don't want to do, and a way of not getting to 1.5. So what we did is we took scenarios out of this database that are consistent with limiting warming to 1.5 degrees in a sustainable and what we would consider the safest way. So we've got 4 main criteria listed here. First of all, of course, they have to limit warming to 1.5 with no or limited overshoot. They achieve net zero in the second half of the century, consistent with what was agreed in Paris. We also limit global reliance on future carbon dioxide removal to sustainability and feasibility constraints that have been assessed by the IPCC. And we also select those pathways that show faster cuts in developed countries than developing countries, recognizing that it's much more feasible for developed countries to move faster this decade, and of course they should do, given their historical responsibility for causing climate change. And so I'm going to just quickly step through what this set of Paris-compatible pathways shows for a few different metrics by 2030. And we think these are all quite relevant as we look to how to close that 2030 emissions gap. So first of all, I think everyone will have heard that we need to halve global emissions by 2030. So on the left-hand side, you see total greenhouse gas emissions. The actual number that we get for 2030 is 48%, and that's faster than the IPCC's median number of 43%. That's because we exclude those scenarios that rely on very high levels of carbon dioxide removal, and that means we need to move faster this decade. On the right-hand side, you can see focus in on energy sector methane in particular. This needs to be dropped very rapidly this decade by 66%. And of course, to do that, that means cuts to fossil fuels, which I'll come on to in a minute. When we look at total methane reductions over the decade, these need to fall by around 34%, so faster than what's agreed in the Global Methane Pledge, suggesting that that needs to be ramped up. And of course, that pledge shouldn't detract from the fact that in the energy sector, methane needs to go much faster. So then moving on to fossil fuels, here we show by 2030 fossil fuel production needs to fall by 40% compared to 2020 levels. On an annual basis, that means reductions of 6% per year. And unfortunately, I think we all know that we're not moving in the right direction yet. As we came out of the pandemic between 2021 and 2022, fossil fuels increased by 6%, so exactly the opposite of what we should be doing. And we're now seeing growth rates more around 1%, which is similar to what they were doing before the pandemic. So still really not going in the right direction. And of course, every month that we delay in cutting fossil fuels will make this transition more difficult. The flip side then, of course, is that we need to scale up a sustainable and zero-carbon energy system. And this is a hot topic at the moment. Germany has suggested a global renewables target be adopted in the COP28 cover decision, and now this is a position from the EU to pursue this, and even the COP28 president has sort of endorsed this as an idea. So yeah, we took a look at what could this look like. On the left-hand side, you can see that renewables should provide over 70% of global electricity generation by 2030. So that's a big growth from where we are today, as you can see in the yellow. On the right-hand side, we looked at what does this mean for how much wind and solar do we need to add every year. by 2030, we need to be adding 1.5 terawatts per year of new wind and solar capacity. These are really the technologies that drive the transition. And we see that if you focus on renewables as a whole, we need to accelerate rapidly, but it's really wind and solar that move the fastest. And so we think that's an important point to highlight as we look to develop a global target. We also looked at what happens to fossil fuels with CCS in the power sector. And these are very marginal. So by 2030, at most around 0.1% of electricity generation comes from fossil fuels with CCS. So any suggestions that CCS is a solution for this decade for decarbonising the power sector in particular are just false. I should actually say, maybe just to add quickly, there are some promising signs. So the IEA's recent analysis suggests that we could be seeing around 0.4 terawatts of new solar and wind this year. So if the recent acceleration rates that we've seen continue, then actually achieving this 1.5 is very reasonable. But that does require continued acceleration, which of course means finance needs to flow into the right places. And we're not seeing the same rates of growth all around the world. So we need to really be directing finance to where it's needed. And I'd just like to end that this was a series of global targets. Of course, we also need to understand what this means regionally and nationally. And we've done this in our 1.5 National Pathway Explorer, where we've developed 1.5 compatible emissions pathways, but also energy benchmarks and benchmarks across different sectors at the national level for over 60 countries. And so you can have an explore on the website and put up the example for the United Arab Emirates here. And you can see, of course, steep reductions in the blue lines. And these are pathways that we've downscaled from, again, the IPCC assessed pathways. We've downscaled them to the national level. So yeah, check out our website if you'd like to find out more. I think that's it from me.
Thank you very much, Claire. That's great. Now I'd like to move on to think a little bit about the added benefits of acting fast on fossil fuels. And so I'd like to introduce Harry Kennard, who is a senior research associate at Columbia University. Harry.
Thanks very much, Paul. And thank you all for joining us. Just skipping forward to my slides. There we are. Yes, as Paul said, I'm Harry Kennard. I'm at the Center on Global Energy Policy at New York in Columbia University. This work follows from some work I conducted at UCL, which was, I was at UCL until 3 months ago, so a bit of a sort of dual association. Sorry, Paul, I might ask if you just... thanks very much, that's helpful. So yes, the central aspect of this work looks at some of the health co-benefits of achieving 1.5 degrees. This is specifically related to 3 domains. First is air pollution. That's a very sort of salient one, which I'm sure many of you will be sort of aware of in terms of the health benefits. The second one, in terms of potential, is in the dietary sector. So that really, in terms of mitigation, relates to consumption of meat products, red meats. And then the final one is slightly less salient, but certainly there's scope for potential action in the active travel sector. So if we encourage people to move more and use less energy-intensive transport methods, that could have co-benefits. The work itself comes out of the CS Now project that we'll hear a bit more about later in from other speakers. The specific way that we sort of examine some of the potential health co-benefits here stepped out of a broader examination of the available evidence in terms of how mitigating against climate change could have impacts. These focus particularly on the most salient health co-benefits. So I'll jump onto the results if this works. Where am I? There we are. Excellent. So yeah, as I mentioned, this is, so in the year 2050, across, here we have 8 global regions. The air pollution sort of pathway comes through exposure to PM 2.5 particulates. anyone who's been watching the news lately will have seen that New York just experienced the sort of more intense aspects of PM 2.5 pollution. That was related to forest fires. These are related to the sectoral emissions across the whole economy, but you can see the sort of most sort of salient aspects that you will be aware of are the emissions from power plants and industry. So the way this graph works is that we have the number of deaths per 100,000 in the population. So it's population normalized. And there are three scenarios that we compare. These are the three different parts of the graph. The first one are the stated policies scenario. These are all based on IEA scenarios, it's important to say. And the stated policies is essentially a sort of business as usual pathway. So these are things that we're are sort of likely to happen if we don't have any further policy interventions. The next, the central graph are the announced pledges. So those are the things that governments have said they will do, but haven't necessarily implemented in terms of a policy output. And then the last one is the net zero scenario, which is compatible with 1.5 degrees of warming. And the key takeaway message is that net zero has substantially lower associated mortality across every global region. You can see that in South and Central Asia, for example, in the bottom panel, substantial reductions associated with cleaning up industry and decarbonizing the processes there. So there's quite a lot to take in this graph. If there are any sort of further interest in this following the talk, we can discuss that further. The next domain that I'd like to talk about is the mortality associated with diet-related risks. This is, again, the same sort of structure of results. Got normalized deaths per 100,000 associated with different scenarios. These are sort of compatible with the IEA in terms of the emissions reduction requirements. The benchmark is essentially we don't do anything on diet. And the two comparison scenarios are an Eat Lancet Commission 1.5 degree compatible pathway and the WHO's dietary guidance. That sort of in the middle doesn't maximize mitigation benefits. The key sort of driver of mitigative potential here is the red meat action. So if we eat less meat, we reduce emissions associated with red meat, and we have a benefit in terms of epidemiologically justified dietary risk. So again, places like South and Central Asia, they have fairly decent consumption of fruits and vegetables at the moment compared to other regions. There's large potential action in the European Union and the other Europe region for those countries that aren't in the European Union. US and Canada is another one which stands out in terms of, in that context, particularly obesity action in that, which doesn't necessarily have a direct mitigation co-benefit, but it's important to be complete about the different risk factors. In the last minute, the final slide shows mortality associated with low physical activity. This is the one that is slightly underspecified in terms of net zero, in the sense that you can get to net zero without making people move more. But if we did take full advantage of potential in terms of expanding access to public transport, getting people to walk to work, this kind of thing, then these are some of the potential health benefits associated with that scenario. I think that probably just about wraps up the amount of time I have to speak on this. But yeah, if there are any further questions on this at the end, please be very interested to take questions. Thanks, Paul.
Thank you very much, Harry. So now I'd like to move on to think a little bit about what the science is telling us about where we're actually heading. And I'd like to invite Piers Forster to speak. So Piers is Professor of Climate Physics at the University of Leeds. If I can make this. There you go. You're right.
Yeah, okay. It's excellent to be here today. So So I also want to speak in my capacity as an IPCC coordinating author of the sixth assessment report as well, and this is part of this EU constrained project work. So I want to look at where the climate science tells us about where we are and what we have to do to try and keep temperatures below 1.5 degrees, and also talk about this recurrent thing that comes up is what is significant about that 1.5 degree temperature. Okay, the first thing I think we have to communicate, a lot of people are talking about when we're going to pass 1.5 degrees, and a lot of this refers to a annually average temperature passing 1.5 degrees, and to do with things like El Nino. And I think it's very important we get across that this is quite different than the long-term temperature target that was set in the Paris Agreement. And to try and give more information about where we are in relation to that long-term temperature target, a whole group of IPCC authors got together to try and give an annual update to some of the key indicators we see in the IPCC report. So this is what the IPCC report would say if it was published today, and this tracks, for example, unprecedented high emissions of greenhouse gases, 54 gigatons equivalent of carbon dioxide, and where we are in terms of surface temperature. And it also shows we approximately halve the remaining carbon budget in the sixth assessment report, and particularly for today's talk, that the temperature is increasing at an unprecedented rate of over 0.2 degrees per decade increase in surface temperature. So perhaps that's a very pessimistic outlook on the current direction, but we also want to talk about what we can do, of course, to change that direction, and we have done some work that indicates perhaps we're increasing it over 0.2 degrees per decade to today, but if we do make some of the changes that Claire was talking about in her talk from earlier, we can absolutely change that direction, and we can halve, or do even better than that, with that rate of warming we expect, and we can make these changes over a very long time. So this is from both action on carbon dioxide, but also action on gases like methane. So that's why it's very important we address the two. But I think what it tells us is that we don't have to wait for a long time to be able to see the change in the direction of travel. And there are interesting interplays, in fact, between which particular scenario we go down for the effects, for the temperature change we expect from the non-CO2 greenhouse gas components, but there's also interest too from how quickly, for example, we get past our coal and we reduce emissions of sulfur dioxide, and that has the opposite effect. But I want to get across that the changes in the short-lived pollutants do have significant implications for the temperature change we can expect even over the next 10 to 20 year time frame. And the very last point I want to talk about is what is so significant about the 1.5 degree target. And in terms of climate science, the 1.5 degrees is not a very kind of hard threshold. The if we do keep below 1.5, it will be okay, and as soon as we go above that, we're all gonna die in some terrible way. That isn't what the climate science tells us. But it also doesn't mean that 1.5 degree target isn't very significant. Because if you look at some of this great work by colleagues at climate analytics in particular, they indicate that if you go from 1.5 degrees to 1.7 degrees or 1.8 degrees, you have increasingly harmful climate impact to contend with. So this is how on the diagram. So the blue bars on the diagram are the impact of 1.5 degrees. The yellow bars are the impact of 1.7 degrees, and the pink bars are 1.8 degrees. And just if I try and illustrate a couple of examples from this top side, you can have a look at the climate impact in Egypt and look at them in India, and you can see, for example, if you go from 1.5 to 1.7 degrees, those impacts go up by about 100%. So what that tells us is perhaps the 1.5 degrees isn't a very hard climate threshold, but it is a significant one. And if we can really work to keep below that, or try as much as possible, we will really make a very significant, it will have a significant impact on the outcomes we expect.
Okay, thank you very much, Piers. So I'd like to move on to another talk a little bit, following from what Piers just said about what would happen if we did actually exceed 1.5 degrees. I'm going to speak for this one. So this is a project which is looking at overshoot pathways. And overshoot pathways are what some people have suggested might be the way forward if they think 1.5 degrees isn't feasible, where you overshoot 1.5 degrees by a certain amount. And here we looked at a low overshoot, a high overshoot, and a very high overshoot, 1.6, 1.8, and 1.9 degrees. And then you use carbon dioxide removal technologies in the second half of the century to bring the temperature back down to 1.5 degrees. And so we assumed that in each case the temperature would be reduced to 1.5 degrees by 2100. So we have these pathways that are shown on this diagram, where the red one is the current NDC's pathway, which goes to about 3 degrees by 2100. And I'm going to mainly focus here on comparing the very high overshoot, the 1.9 degrees, and the no overshoot, so the orange one and the green one. Now, the height that you can get to, or the maximum temperature you can get to, depends on the climate sensitivity and on what you think the level of carbon dioxide removal is feasible in the second half of the century. So 1.9 degrees is about as high as we think you could feasibly go. But this is the graph of greenhouse gas emissions on the left-hand side, so you can see how they change over time. So essentially, in a very high overshoot scenario, we continue with NDCs for about 20 years, longer than now, before we start having a heart attack and start cutting as fast as we can. So it's essentially a delayed climate action. And because it's delayed, it means that you need to have a very high level of negative emissions in order to return the temperature back to 1.5 degrees by 2100. So it's actually about 37 gigatons per year you would need from about 2080. But you need a lot of of carbon dioxide removal from a much earlier stage than that. It's highly contentious whether you would actually be able to do that in practice. So most integrated assessment models assume up to maybe about 20 gigatons carbon dioxide removal per year, something nearer the high overshoot. You can see the low overshoot has much less, and the no overshoot could have less again. It's highly contentious for a number of reasons. So, for example, would it be possible to build the CO2 capture infrastructure, the CCS infrastructure that we need, and actually store the CO2 safely? Is there the sorts of levels of biomass that we would need in order to get negative emissions from biomass with CCS plants? Or if we looked for afforestation and other nature-based solutions, would they be feasible? Is it possible to put in place I should say that biomass needs to be sustainable, and that's a really key question. There's a lot of evidence that's increasingly building that most of the biomass that we do use at the moment is not sustainable, and we need far more biomass looking forwards. And then we'll have lots of issues over land availability with the growing population, with food, and with all of the other services that we have from land. There's issues over governance, regulation, and such like. So it's a really contentious area. And we did do a review of carbon dioxide removal, and the experts that looked at this concluded essentially that they didn't think it was feasible to go to the sorts of levels in the very high overshoot scenario. Moreover, even if we thought it was feasible, the economic case for doing it is really quite weak. So the top left graph here shows the energy system costs from a model, from an energy system model for three scenarios: the NDC scenario, the very high overshoot, and the no overshoot. And you can see that there is some upfront costs of not overshooting, but then they're not greatly larger than the other two. And if you want to then go follow the very high overshoot and bring the temperature back down to 1.5 degrees, you have some very high costs towards the end of the century. So you can only make this economic case work if you assume a very, very high discount rate towards the end of the century. Remember, the NDC scenario here is going up to 3 degrees. So this is a really high level of climate change. And the picture doesn't get any better when you start looking at the damage costs, so the increased damage costs by overshooting compared to not overshooting. And that's what's shown in the two graphs on the right-hand side. Now, I have two levels of damage costs here. One at about $1 trillion per year, peaking in about 2050 to 2080. The other one's peaking at about 10 per year. And I've put those two on there because they use two different damage cost functions, and that's to communicate the message that we have no idea really exactly what the damage costs are going forwards. There's a lot of contention, and that was one of the findings, actually, of AR6, the most recent AR6 report, is that there's different methods of estimating what damage costs are. So, for example, using process-based models to look forwards, or using econometric-based methods to look back at climate damages that have already happened. And we get quite different results from those, an order of magnitude difference. So there's a lot of uncertainty over damage costs. But you need to add the damage costs on to the graph on the top left to start thinking about the actual costs of overshooting. And then you would ideally take account of the co-benefits that Harry was just talking about too. And so the economic case for overshooting really becomes very weak compared to taking action now. Moreover, if you do overshoot, it will have substantial impacts on nature. So in the middle of the century, where the temperatures have the greatest difference, in the graph on the top left, you can see that the Arctic is several degrees warmer in the high overshoot scenario compared to the no overshoot scenario. This is done using the UK Earth system model, I should say. And even at the end of the century, so by the end of the century, we go back to a 1.5 degree average in both scenarios. So you can see that the Arctic is still substantially warmer. We have hysteresis in the system where we've lost sea ice potentially permanently for a much longer period. We actually even have a little bit of cooling then in the Antarctic. So we have an impact. So going back to 1.5 degrees, it does reduce the temperature over most of the planet, but there is some hysteresis, and there is a tipping point in the Arctic that we would hit. And this graph on the left-hand side scares me even more. So this is the risk of biodiversity loss in individual species groups. And this is the percentage lost of each species at 1.5 degrees and at 2 degrees. This is from some work from colleagues at the University of East Anglia. And so, for example, for moths, by going up to 1.5 degrees, we're looking at losing about 20% of species. Going up to 2 degrees, we lose about 40%. So let's not kid ourselves that 1.5 degrees is a good thing. 1.5 degrees is just trying to minimize the damage, not trying to avoid damage. There's still quite a bit of damage, but it gets a lot worse if we go to 2 degrees. And if you think about how species work in practice, you will have a certain amount of migration as temperatures change, as the climates change. Now, in a 2-degree scenario, you'll see species moving. In an overshoot scenario, you're going up to 2 degrees and everything will have to try and move. And then you come back to around 1.5 degrees and everything has to move again. And all the landscape has changed because the time that you actually have hysteresis is 30, 40 years. Or the time you have a really high temperature above 1.8 degrees, it's about 30 or 40 years. So the landscape is changing. And so arguably it could even be worse for biodiversity. It's worse on a number of other things. So, for example, tree cover. You have quite a bit more tree cover in an overshoot scenario by 2100 than you do in an overshoot scenario. Finally, it's going to affect civilization globally. And I was very grateful that Piers showed the last slide that he showed, because he showed some of the impacts at 1.7 degrees, 1.8 degrees compared to 1.5 degrees. Now, some colleagues of mine did a paper in 2019 looking at the impacts of climate change on the SDGs, and they found that climate change adversely impacts quite a few. On the other hand, mitigation can have some quite positive effects across a number of SDGs. Not all of them. There are some negative impacts, but predominantly it's positive. And so I think we need to also keep that in mind. So with that, I'm going to finish there, and I'm going to pass over to Carlon, who's going to talk, Carlon Mendoza, who's the Climate Policy Advisor at Climate Analytics, and he's going to talk about what all of this means for the GST.
Hi, good afternoon, everyone. Thank you. Thank you, Paul, for the introduction. Firstly, let me apologize that I don't have a fancy slideshow with colors and graphs to show you all, because I'm coming from the perspective of an AOSIS negotiator currently in the room dealing with the global stocktake. And for us to understand exactly what this topic or this conversation we are having today about the value of 1.5 ambition for the GST, we need to understand exactly what that GST process is. And it's rooted in Article 14 of the Paris Agreement, whereby countries or parties and non-party stakeholders are allowed to collectively assess the progress made under the Paris Agreement. And this is the first time this is happening since the inception of the Paris Agreement. And it is imperative right now, and given all the discussion that we have heard on the table about the effects of an overshoot or the effects of living in a world that is warming at 1.7 or 1.8, is imperative now that we utilize this process whereby we take the submissions of parties and non-party stakeholders in terms of the format of that technical dialogue that occurred, and utilize that information in order to progress our NDCs and progress our climate ambition so that we would not reach to that position where we're at. So, where we're headed. So I would like to leave 6 messages that you may hear again in some negotiation rooms, but 6 messages in my 6 minutes about what is important or what we can do to link this science or this 1.5 trajectory or the ambition, towards scaling up our ambition as countries and as parties in this process. So the first thing I would say is that this is a matter of urgency. It is a matter that is clear across all themes under the Paris Agreement. We need to urgently deal with matters under mitigation, adaptation, and means of implementation, including finance, capacity building, technology transfer. The second message is that this is a unique situation or challenges that we have as small island developing states and LDCs, least developed countries. And in order to achieve the goals of the Paris Agreement, these activities under mitigation, adaptation, and means of implementation need to be taken seriously, and it needs to be scaled up immediately. And hearing the discussion on the table, we have to let the science lead, which is my third point, in understanding exactly the best available science to us and letting that take the forefront in all the decisions that is going to be made under this GST process and processes to come. And in that, we also want to make sure that equity needs to be operationalized. And when we speak about equity being on 3 levels: between countries, so that no country is left behind, intergenerationally, because every decision that we make here affects future generations. As Claire stated, a delay in phasing out fossil fuel affects the temperature goals. So any delay that we have at this moment affects what is being done in terms of intergenerational equity. And within countries, we need to have an equitable approach within countries and within society. So the speakers also spoke about the need for finance and that means of implementation in terms of there's a need for continuity, there's a need for progress. In terms of capacity building for small island developing states, it's not about coming in and just giving a workshop or giving funds to deal with programs, but it's about long-term capacity building and ensuring that there is continuity within the progress, ensuring that the technologies that are transferred are operationalized within the countries so that we don't have that issue of overshooting, or we don't have that issue of not being able to really effectively scale up our ambition. And finally, international cooperation. I believe panels like these allow us to hear the science, and I think that's very important, where we are able to see, seeing that graph that Piers, that chart that Piers had up in terms of the percentage increase of annual expected damages from tropical cyclones, and particularly noticing it for all countries. I'm very happy that the chart was reflected small island developing states, United States, and other countries, LMDCs, as the like, because it shows that this is a global problem. It's not just unique for SIDS and LDCs, but it is a global problem. So with that, I would end my presentation or my conversation, and I'll turn over to Paul. Thank you.
Thank you very much, Carlon. So for our last speaker, I'd like to talk about why 1.5 degrees is important to the UK. So I'd like to introduce Iliana Cardenes, who's Head of Climate Resilience Evidence and UK Science at the UK Government. Iliana. Yes, there's a button there. That's it.
There we go. First of all, I'm sorry that I was late. I've been in negotiations for the UK, just like Carlon. I don't have any slides, so you just have me to hear. But yes, so apologies I'm late, and I'm going to have to sort of run out as well after sharing some thoughts, because we're ongoing with our negotiations. But I really wanted to sort of come today and have a little reflection, very similarly in the same lines as Carlon, around why 1.5 is really important to the UK. So I wanted to touch on that a little bit first, and second, I want to talk a little bit about the GST. And Carlos very conveniently has given us a really good introduction as to sort of what the GST is, and I wanted to sort of dig in a little bit deeper into sort of what are some of our ambitions and what we think the GST should could achieve. So the UK's overarching ambition in the negotiations is to ensure that 1.5 is kept within reach in this critical decade across all the negotiations. Because as many of you know, when you look at global commitments to reduce emissions and targets adopted to date and what they will deliver, what we know for certain is that risks are increasing with every increment of warming, and keeping global temperatures to 1.7 and 1.8 is just not enough to limit the worst damages that climate change will have. If we look at the evidence that Piers presented, for example, on impacts in 2050, every increment beyond 1.5 has significantly higher impacts for every region in the world. So, as Carlon was saying as well, this harm falls on all countries. It's a global problem, but particularly those that are most vulnerable and least able to adapt to climate change. So really the equitable outcome really is to limit warming to as low as possible, so 1.5 with no or limited overshoots. Carlon was talking about the ground impacts of climate change. It's really very serious. So, and we don't know where some of these impact and feedback thresholds between 1.5 and 2 might land. So we really need to aim for 1.5 to reduce risks. And if you look at the impacts of overshooting, and Paul was telling us a lot about that, many human and natural systems will face really severe additional risks compared to remaining below 1.5. So also Harry's slides, he showed us some of the health co-benefits of increasing ambition. So it's really a win-win for all of us, and the importance of increasing ambition. And as we've seen, carbon dioxide removal also features quite prominently in a lot of the scenarios. But obviously Claire was pointing to some of the 1.5 scenarios that actually keep us within 1.5, and CDR might feature in some scenarios, but we must remember that CDR is not the solution. Greenhouse gas emissions reduction is the focus, and CDR in some of the hard to abate sectors is part of the solution, but certainly not one of the biggest focuses, because it is costly, as our colleagues have been talking about today, very, very costly, and seems just not feasible. So. So during overshoot, every increment of global warming brings severe impacts. So the lower and shorter the overshoot were to be, if we look at models, the less severe these impacts will be. Depending on that magnitude, on the duration of the overshoot, some impacts will release additional greenhouse gases. So we just don't know, it's going to be much harder to bring temperatures back down, and some impacts are going to be irreversible, even if warming is reduced. So really overshooting is really not where we want to go. We have to avoid it at all costs. And then we look at related losses and damages from climate change, and they will escalate very quickly from climate change, from every increment of global warming. They're higher for 1.5 that they are present already. So they're even higher at every single increment beyond 1.5. So with further warming, climate change risks become increasingly complex, right, as we've seen, and just very, very difficult to manage. So really, when we look at AR6 and the assessments of climate risks, and we see that they are much higher than they assessed at in AR5. So future risks could be much worse than we're assessing right now. So the best thing is to be as ambitious as possible. So translating this back to the negotiations and sort of what does this mean for the GST, and what is the GST, right, as an ambition, as a vehicle for ambition? What do we mean by that when we say that as negotiators? Well, I think the GST can really help us to build political momentum. Now that the technical dialogue, as all of us know, is ending, the GST can really try and keep the 1.5 outcomes in reach and set up sort of really clear next steps for climate action in the critical decade that we have left. So in our view, in the case with the negotiated GST outcome, needs to outline really clearly immediate action that is required across mitigation, adaptation, and means of implementation, as well as provide sort of NDCs, guidance for NDCs that are coming up. And more specifically on 1.5 and sort of the mitigation outcomes and where we want to go with that, our view is that we have to have much more tangible outcomes that take us beyond what was achieved both at COP26, even though we're very proud of the Glasgow Climate Pact, and certainly beyond what was achieved at COP27. We really think we need to work together to build outcomes that go beyond repeating what was previously agreed at previous COPs on keeping 1.5 within reach. Elements that we think are really important that allow us to be 1.5 aligned. We know it's challenging, but we've seen that it is possible, and we need to increase ambition. And specific elements that we would like to see are outcomes that move the conversation forward on the energy transition, particularly on including fossil fuels and coal. We really think it's extremely important that these are part of the discussion. That we have a global roadmap for the highest emitting sectors. And also that we set out expectations for the next NDCs, as we've been discussing. So so countries really need to start thinking about those next NDCs, really informed by the global stock data. It's a really good opportunity to ensure that they are 1.5 aligned economy-wide, right, across all sectors, and across all greenhouse gas emissions as well, with absolute targets. So revisiting 2030 NDCs as part of this exercise is where we think we should go. If we look back at some of Claire's slides, she tells us about the many different pathways that are still available and achievable to reach 1.5, and this is where we need to focus our increased ambition. And in the UK, just to finish up, we fund research that is helping us develop evidence-based policy and make decisions that are informed by climate science. So a lot of the science that we're talking about today is funded by us, by the UK, through a program called Climate Services for a Net Zero World. And so I guess that call from us to listen to the science. There's some fantastic science coming out. Obviously, the IPCC AR6 and recent advancements, and really we need to increase ambition. So that's all from me. Thank you very much, Paul.
Thank you very much, Iliana. It's great. Okay. So we're now going to move into a Q&A session. You've heard from everybody here. We have about just over 20 minutes left, so I want to spend half of that time, or maybe up to half of that time, for general questions on anything you've heard here, and then the remainder of the time, thoughts on the question that we posed earlier, which I'll put on the screen again. So for those online, please do use Mentimeter. Those in the room don't need to. Just you can put your hands up and we'll get a microphone to you. You need a microphone so the people online can hear you. And for those online, there's two questions now. So the first, if you log onto this link, you'll find a box for asking questions in the Q&A. And then if you go to the next question, you can put your thoughts on the question that we gave to you. And the question that we gave to you, what are the main elements and messages coming out of these scientific findings that will increase the ambition for the global stocktake? But for now, I'm going to leave the Mentimeter on. And I'd like to invite the first question. So we have a couple in the room. I think you're first. Can we have somebody with a microphone, please? So this gentleman here.
Thank you. Hi, Tim Stickings. I'm a journalist at The National. I want to follow up on the overshoot and what it means for the GST. I mean, I'm particularly interested in what Carlon might have to say about this, or anyone. How much should the GST then distinguish, given how much we've heard about what a disaster the overshoot would be, about taking stock of actions that are on track for 1.5 with an overshoot, or being on track for actions that don't have an overshoot? Thank you.
Try again.
Thanks for the question. I believe that the last technical summary report from TD 1.2, the technical dialogue, spoke to the possibility of overshoot and accounting for that. From the EOSIS perspective, we have indicated that should not be something that the GSTs should be focused on. It should be that every action counts now, and every decision, we need to make decisions in terms of the thematic areas of mitigation, adaptation, especially in mitigation, of course, so that we can be on path to the 1.5. I believe Iliana might also be able to give some perspective into that question as well. But for now, that we should be on track focusing on pathways to 1.5 and not an overshoot.
Thank you, Carlon. Great question, and I would echo what Carlon has said. I think our position is very similar. We think that 1.5 is where we should focus our attention. It is still feasible. We need to increase ambition, and we need to work. So that's what the GST needs to find pathways forward for. How do we ensure that we do not overshoot? Because overshooting, as you've said yourself, is dangerous, and we need to find a way forward on 1.5. And there are ways forward. There are ways forward. So the GST is a vehicle to ensure that we have the space to ensure that those are the conversations that we are focusing on that increased ambition to make sure we keep within 1.5. And on that note, I'm going to go back to the negotiations. That's okay. Yes, to make sure 1.5 is still within reach. All right. Thank you very much.
Thank you. Thanks, Iliana. Good luck. Okay, thank you. We've got a second question over here.
Yes, first to thank you so much for the emphasis on loss of life, both of humans and of our nature neighbours, and what that means. We often don't talk about death and the increase based on every fraction of a degree. I'm sorry our colleague just left because I wanted to ask about political will. We've appreciated the UK, for example, talking about 1.5 and holding it. But how do we get political will within when the UK, for example, and it's not just the UK, is giving licenses for more oil and gas drilling, is not allowing for sustainable community groups to put onshore wind turbines within England. I appreciate not the other parts of the UK, but within England. Solar panels are for the luxury. Sustainable economic systems is not really discussed, diet, etc. So I appreciate from your side on research, how maybe do you try to engage politically within a country to get them to do inside what we need to do if we're really talking about mitigation? Thank you.
I'm going to bring in Piers Forster for this one, with his another hat that he has, which is a member of the UK's Climate Change Committee, which advises the UK government.
Yeah, so just for those people that do not know UK kind of politics intimately, we have an independent committee that advises government, and I also sit on that committee, and you're absolutely correct. Kind of we, the committee, think that the UK government really was one of the leading countries in really setting a very tough commitment for 1.5 degrees. But what is done in things like allowing for expansion of kind of fossil extraction does really not set a good international message at all about our ambition, and that we are no longer one of the leading countries for climate action, unfortunately. But I would say I'm not despairing completely, because we are seeing far better commitment from a lot of our EU colleagues that are really as a result of the conflict in Ukraine and other things. They are really ramping up the investment in the renewable energy industry, and we were expecting them to expand their coal industry and things, but that expansion hasn't really occurred. It's not doing well, and we're also seeing very similar signs in other countries like the US, for example. But that isn't still good enough. So just as like Claire put in the talk, we can't do it in one or two countries. We have to do it everywhere, and this is where I think I would like to see attention on the just energy transition partnerships. They have a key role in really trying to deliver some of that can finance.
Thanks, Piers. I'm going to comment on that in a second. Claire has to leave, but I think your co-author Neil is in the room.
Yes. Sorry.
Would you like to swap in? We'll do a quick substitution in case anybody has any questions on Claire's stuff. Thank you. So from my perspective as a researcher looking at mitigation, I think what I try to do is move on the conversation from how much will mitigation cost, because it's the wrong question, and so it leads to the wrong answer. You need to first of all look at cost and benefits on the wide scale, but also think about all of the other benefits you have, which don't go into that simple, very simple-minded kind of question about a basic cost of moving, looking at wider political things around economy, energy security, and everything else. And I think doing that, you can make a much stronger case as well, particularly to take actions earlier. I'd now like to take a question from online. So Rachel.
Yep. So online we've had a question which I think is for Claire and now for Neil. Does the Pathway Explorer look at geophysical constraints of countries and what is realistic and viably possible for them to reach a 1.5 pathway?
Yeah, thank you for that question online. So the analysis that we put out today is based on the latest global pathways that they account for the different context of different countries in terms of their renewable potential, their potential for different technology rollouts. So they are grounded in what the models show is technically feasible and achievable, and that includes some geophysical constraints, for example, around how much carbon dioxide could be stored geologically, and other issues like that. So they very much show a transition which is grounded in what is technically feasible and achievable this decade.
So this question is for Carlos. So you talked about the 3 dimensions of equity, and thank you so much. But I was wondering if there is any also discussions about the 4th dimension, which is equity for other species, especially since we are going through another mass extinction soon.
Thank you for the question. I would say that within the negotiation room, because we are based on the principles of the best available equity and the best available science, not necessarily that there has been a specific reference to the 4th limb of equity being species, but I can say that there are party members who have referenced the attention or the special consideration for the ecosystem and Mother Earth and nature in different streams of negotiations, which all feed into the GST process. So I can assure you from that perspective, but it's something that we would now take into consideration in terms of how we go about in negotiations. So thank you for that.
Thank you, Carlon. Do we have any further questions in the room or online for any of the speakers before we go on to the question that we've posed for everybody? And I should warn our panel, I'm going to ask all of our panel members for their response on that question briefly before we kick off with everybody else's. We have one question at the front.
Thank you very much. For you, Harry, was it? What do you see as the ideal concoction of energy sources to achieve this 1.5 goal?
In the context of health, particularly, or
yeah.
Well, yeah. I mean, so the clearest thing is using technologies which don't have particulate emissions, right? So that's hastening the shift away from coal, because that's one of the sort of strongest particulate emitters. Depends exactly on where you are in the world in terms of what you can deploy, but there's also questions to be asked specifically about the use of biomass in terms of how that's deployed, because there are particulate emissions associated with biomass, which is why it's not necessarily incorporated as one of the sort of central renewable sort of, best of all worlds options. So, obviously wind and solar don't have any negative health impacts. So those sort of considerations are important. I think is that.
And where do you see nuclear fitting into this?
Nuclear, I mean, my personal position on nuclear is that it's an essential part of the mix, because we're in trouble otherwise. The health associations there probably have to be calculated in a holistic sense. If we have, if we deploy nuclear in the way that we know we can, then the health impacts are totally minimal. So.
Okay, thank you very much, Harry. Okay, so I'm going to move on to our question now. What are the main elements and messages coming out of these scientific findings that will increase the ambition for the global stocktake? I think I'm going to ask the panel first, so I'm going to move along in this direction if I can. So I'd be interested in everybody's views, and then I'd like to open it to the room, and I'd like to open it to online too. So if you're online, please go to the next question, and you can put in your views there, and we'll read some of them out. Piers.
Well, yes, I think it would answered very well by my colleague from the UK, Iliana, that absolutely says it should focus on the ambition aspect of what we have to do to really get to 1.5 degrees. And I do think she brought up a good point. We have to do it under the kind of mitigation, the adaptation part of that, but it also covers the implementation part of that. And so it's not going to happen without the effective kind of financing.
Yeah, I think one of the things that I was reflecting on hearing the talks is that we need to tell a sort of a holistic story to drive ambition in the global stocktake. And so that's about the urgency, feasibility and desirability of limiting warming to 1.5 degrees. And I think different speakers in terms of talking about the risk of overshoot or the significant growth in climate impacts for every 0.1 degree beyond 1.5 degrees have talked about the urgency of limiting warming. We've heard about the desirability of it in terms of the co-benefits. And then I guess the work that we've put out today is just, again, putting home the message that 1.5 degrees is still within reach. The changes that we need to make, they're large, they're rapid, and we shouldn't underestimate the escalation in ambition which is needed, but there is an acceleration which is still achievable. And so I think, bringing together urgency, feasibility and desirability.
Thank you. Harry?
Thanks very much. So I spoke mainly about the health co-benefits of mitigation activities. It's also worth emphasizing in terms of, as we look at the global stocktake, the health impacts related to temperature increases in general. So that's the the direct health impacts of climate change. There are some pretty alarming potentials for some feedback loops, which I think are worth highlighting as well in this. So one that I saw yesterday, I think it was, several of the UK's coal power plants have been put on standby for the summer because of the concerns about increased energy use related to air conditioning. So this is a good example of how things start to get more difficult the hotter things get, because you have increased desire by a population to not experience horrendous temperatures. That puts strain on electricity grids and electricity systems, which in turn means that we are more reliant on harmful sources of energy, such as coal. So that's sort of a very specific example of the kind of things we need to be thinking about in terms of costing these aspects into the full equation of taking into account health as well.
Thanks, and Carlon.
Thank you. I guess to sum up, I think the critical role that nature-based solutions can play within this GST process is a critical message coming out of the findings in relation to the science in terms of utilizing our natural ecosystem and utilizing some learnings or scientific knowledge from indigenous persons, from cultures, and from peoples to assist with the climate ambition is one message that can come out. And secondly, I think it was said by one of the panelists that leading on renewable energy system transformations in terms of wind and solar transformation is something that is important and a key message that can feed into the GST and then can be able to assist parties and countries in implementing that transformation within their parties and within their country and their NDCs. So that would be my answer.
Thanks very much, everybody on the panel. So we said this would be an interactive session, and I'd now like to pass over to anybody in the room who has a view on this question, or anybody online.
Thank you. I'm Marcela Chacon from Bayer, here with the ICC. And I would like to say only that even though mitigation is great, and you've been talking about that, if there's no adaptation to it and the implementation, as you said before, there's no way we're going to get out of this as with less harm as we want. So I would say you cannot talk about mitigation without putting in the equation adaptation. They have to go hand in hand. Like mitigation and adaptation are the new R&D for the private sector. And I think that's the way it has to be seen. They have to go all together hand by hand.
Thank you. I think that's useful. And actually, Iliana talked about a climate services program that the UK government is funding. One part of that is looking at the links, the synergies between mitigation and adaptation and trying to map them. I think it's a very good point. Rachel, we have a comment from online.
Yeah, so online we've got the absolute urgency of taking mitigation action now, and we also have that the costs of not acting are much higher than the costs of acting.
Would anybody else like to make a comment on this question? Oh, we have one at the far corner, please.
Hi, thank you very much for an interesting session. My name is Michelle Tichelaar from Stanford University. At the risk of turning this into a, here are all the things you forgot to talk about comment session, but from my end, I noticed that a lot of the conversation was around energy systems. I work a lot in food systems, and as 30% contributor of greenhouse gas emissions, I think it's really important to start thinking about what those pathways look like, including their adaptation co-benefits or trade-offs, as well as those around health and other food system outcomes. And other than that, really wonderful perspectives. Thank you so much.
Thank you. I agree. Okay, I don't think we have anybody else who's desperate to say something, so it's 3 minutes to 1, so I think we'll draw this session to an end. So thank you very much all for coming. It's been really appreciated, and I hope everybody's found it useful, interesting. We do have lunch outside now, hopefully. I haven't checked, so it's a plant-based lunch. It's fully compatible with the Eat Lancet diet that Harry talked about, I'm pleased to say. So it is the future, hopefully. So thank you all very much.